So we'll be starting with a new topic called mesh analysis. Now what is mesh analysis? So mesh analysis is a simplified form of KVL, Kirchhoff voltage law. We apply KVL only to mesh. We apply KVL only to mesh and we make certain assumptions. What are the assumptions which we make? First assumption is voltage across resistor is always voltage drop that is minus IR. And second assumption is while applying KVL to a particular mesh, current in that mesh is more than current in any other mesh. Current in that mesh is more than current in any other mesh. So we have to see what are the steps to solve problems on mesh analysis. What are the steps to solve the problem on mesh analysis? Step number 1, assume direction of current in all the mesh for simplicity. Assume in clockwise direction. So for simplicity, we will be assuming it in clockwise direction. Second, name the assumed current as I1, I2, I3 and I4 and so on. Third, apply KVL to all the mesh in the direction of the assumed current. Apply KVL to all the mesh in the direction of assumed current with following assumptions. So what are the assumptions which we have to make? Assumption number 1 is voltage across resistor is always voltage drop. Voltage across resistor is always voltage drop. Second assumption is while applying KVL to a particular mesh, current in that mesh is more than current in any other mesh. And fourth step is solve simultaneous linear equations. Simultaneous linear equations to find out the unknown mesh current. So don't worry, we will be understanding each and every step. We will be starting with a simple sum so that we can understand all these steps. Sum 1 is find current in 2 ohm resistor. So this is like this, 10 volt, 6 ohms, 1 ohm, then this is 2 ohms, this is 3 ohms, this is 10 ohms, this is 20 volts. This sum we have also solved using Kirchhoff voltage law in the previous video. Now we will be solving this using mesh analysis and compare the answers whether they are coming correct or not. So first we will see, assume the direction of current in all mesh, assume it in the clockwise direction. So this is assumed. Second is name the assumed current as I1, I2 and I3. Apply KVL to all the mesh in the direction of the assumed current. So now we will say apply KVL to mesh 1. So this is mesh number 1, this is mesh number 2, this is mesh number 3. When I apply KVL to mesh number 1, starting from this point, I say this as plus 10. We have to consider the assumption voltage across any resistor is voltage drop. So I say minus 6 I1 irrespective of incoming and outgoing current. Then I say minus 1. Assumption says that while applying KVL to a particular mesh, the current in that mesh is more than the current in any other mesh. So current in that mesh is more. We are applying KVL to mesh number 1. So current I1 will be greater than I2. So I write here I1 minus I2 equal to 0. So this is 10 minus 6 I1 minus 1 I1 plus I2 equal to 0 minus 7 I1 plus I2 plus 0 I3 equal to minus 10. This is my equation number 1. Next I will say that I am apply KVL to mesh number 2. When I apply KVL to mesh number 2, what do I get? I get minus 1, but I am applying it to mesh number 2. So current I2 will be greater than I1. So I say minus 1 I2 minus I1 minus 2 I2 minus 3 I2 I'm applying it on mesh 2. So I say I2 is greater. So I2 minus I3 equal to 0. So this will be like this, plus I1 minus 2 I2 minus 3 I2 plus 3 I3 equal to 0. So I1 minus 6 I2 plus 3 I3 equal to 0. This is my equation number 2. Then I say apply KVL to mesh number 3. I will always, in mesh analysis, I will use always the word as mesh and not loop, because in KVL, Kirchhoff voltage law, we can say mesh, we can say loop also. But here we have to specifically say mesh number 3. When I apply KVL to mesh number 3, starting from this point, I get minus 3. I am applying it to mesh number 3. So current I3 is greater than I2. So I write here I3 minus I2 minus 10 I3 minus 20 equal to 0. So minus 3 I3 plus 3 I2 minus 10 I3 minus 20 equal to 0. 0 I1 plus 3 I2 minus 13 I3 equal to 20. Equation number 3. So now solve simultaneously and find the value and get the values of I1, I2 and I3. So we'll find the values for I1, I2 and I3. Minus 7, 1, 0, minus 10, 1, minus 6, 3, 0, 0, 3, minus 13, 20. So I1 is 1.3404. I2 is minus 0.6170 and I3 is minus 1.6808. So current flowing through 2 ohms is I2, but we got a minus sign, so we say that the assumption is wrong. I2 we have assumed it through 2 ohms, it is flowing in the right direction, but I2 is flowing in the left direction through 2 ohms. So current through 2 ohms is I2, which is equal to 0.1670 amperes in the left direction. So we will write the answer as positive and the direction to be the correct direction and not the assumed direction. If answer is coming negative, assumed direction is wrong.